Hi there. In this video, we are going to attempt to evaluate the indefinite integral below using long division and partial fraction decomposition. This is a pretty complicated integral that uses a lot of techniques, so I will do my best to take you through it. Okay, the first thing that you want to notice as we work through this problem is that the numerator is a higher degree than the denominator. When this happens, your first line of defense should be to do long division. So I'm going to take the numerator, 3x cubed minus 6x squared minus 5x, and I'm going to just do long division with x squared plus 2x minus 3. And if you've forgotten how to do long division, we want to see what can we multiply x squared to get us the 3x to the third power. I need to make sure to put my constant term out here at the end, and what we need to multiply by is 3x, so I'm going to multiply. We get 3x to the third, 3x times this plus 6x, and we're going to get a minus 9x, and then we're going to have to subtract this quantity, and my preferred way to subtract is to add the opposite of everything. So when I add those up, those are going to zero out. I'm going to get negative 12x. Oh, there should be a squared on that one. And then plus 4x. And then our second iteration here, we are going to, what do we multiply the x squared by to get a negative 12x squared? And that would be a negative 12. So I'm going to do a negative 12 up here. And when I multiply that out, I am going to get negative 12x squared minus 24x. That plus 0 comes down, and we're going to get a plus 36. And we're going to subtract. So I like to, again, add the opposite of everything. So that's going to zero out. That's going to be 28x, and that's going to be a minus 36. Okay, and this point we can't really divide anymore. This is our remainder. So we're going to simplify this. It's going to be the integral of 3x minus 12, and then plus 28 minus 36. That still needs to get divided by our x squared plus 2x minus 3, all dx. Okay, so at this point, this is a little bit better. These two terms we know how to take the antiderivative of. This one we still have to decide what we want to do with it. So I think because the denominator is factorable, I can factor this into an x plus 3 and an x minus 1. I'm going to try partial fraction decomp. So I'm going to do that over here, partial fraction decomp. And I am not going to simplify too much, so I'm just going to write this at 28 minus 28x, excuse me, minus 36 over x plus 3 times x minus 1. I'm going to put my a over x plus 3, and I'm going to put my b over x minus 1, and I am going to do my partial fraction decomp. When I do that, I get my, what does my a equal here? My a is going to equal 30, and my b is going to equal negative 2. I'm not going to take you through that whole process, so if you need to practice partial fraction decomposition, you can look at some other videos on that. Okay, so let's go ahead and rewrite this. Is going to be 3x minus 12, and then I have a plus 30 over x plus 3 and a minus 2 over x minus 1 dx. And at this point now, I can take antiderivatives. Because these denominators are of degree 1, when I take antiderivatives, I'm going to get natural logarithms. So we should end up with 3x squared over 2 minus 12x plus, I'm going to factor out the 30, take the antiderivative of 1 over x plus 3, which gives me the natural log of the absolute value of x plus 3. And then I have a minus, I'm going to factor out that 2, natural log absolute value of x minus 1. And we're almost there, plus c. Okay, so essentially we are done at this point. This is the correct answer, I hope. But sometimes you do need to kind of consolidate and condense those natural logarithms. So if we wanted to do that, we could rewrite this natural log of x plus 3 to the 30th using properties of logarithms minus the natural log of x minus 1 squared. Since we have a subtraction, we are going to end up dividing, so x plus 3. And since I have an even power, I do not need the absolute values, right? Because the 30th power of anything is going to be a positive number. And then the same with the squared, so I don't really need those absolute values anymore. And we could consolidate that entire portion, right, to look more like that, which on a multiple choice kind of a test, you might have something that looks more like that. Whew. So we have done our problem. Again, just to kind of summarize, the first thing we did was our long division here. We rewrote an equivalent expression over here, and then we recognized that we needed to use partial fraction decomposition for the rational expression portion. And once we did the partial fraction decomposition, then we could take the antiderivative. I hope this helped you better understand how to tackle these complex problems. Remember, write your work down, be organized, and most importantly, don't give up. Thanks for watching.